Hello, this video will discuss a basic principle regarding altitude and distance management for a descent. As usual, I will start a video with one of my lovely triangles here, where one side will be the altitude A and the other the ground distance D. We will assume we want to descend on a 3-degree glide path from a certain altitude. So, the tangent of this 3-degree triangle would be A over D. However, since we measure the altitude in feet and the distance in nautical miles, we will take that into account and divide the altitude by 6080, which is approximately how many feet there is in 1 nautical mile. If we rearrange this formula to get the distance, we would see that the distance would be equal to altitude over 6080 times the tangent of the glide path angle, 3 degrees. If we consider the glide path to be constant through the descent, we can say that the distance is only affected by the altitude. We now have a rule of thumb which says the distance required is 0.0031 times the altitude A, where A is measured in feet. However, to make this calculation more simple, we can increase the factor of 0.0031 by 1000 and decrease the altitude by 1000 as well. We can also round up the factor of 3.1 to 3. Now it looks much more simple. The distance required is the altitude multiplied by 3, where altitude A is the 1000th part of the altitude measured in feet. So for example, if we are flying at an altitude of 10,000 feet, the A would be 10. If you're at 5,000, it would be 5. If you're at 500, it would be 0.5, and so on. So if you are cruising along at an altitude of 30,000 feet, your top of descent would be approximately 30 times 3, 90 nautical miles from your touchdown zone. Make sure to take the field elevation into account if it's of considerable value. This principle can also be used the other way around, that is, to find the altitude we need to be at if we know how many miles we are from the touchdown. Often the approach controller will give you an estimate of nautical miles to be flown while being vectored. So imagine you hear 50 nautical miles to touchdown during your vector. Simply divide the distance given by 3 and add 3 zeros. So for 15 miles, that would be 15 divided by 3, which is 5. Add 3 zeros and you have 5,000 feet. Take a look at your instruments, and if you are at approximately this altitude, you may continue your descent with a rate that gives you a 3-degree path. This rate will depend on your ground speed, and you can find a video on this topic on my channel. Anyway, I hope this little trick helps you up in the air, and if you have any questions or suggestions, feel free to drop a comment down below.